and I instruct the Syncrometer program. Today we have a very special guest. Dr. Hulda Reger-Clark is with us. Dr. Clark has completed her undergraduate studies at the University of Saskatchewan. Then, after studying at McGill University, she went on to the University of Minnesota, where she received her doctorate in physiology. 10 years of government-funded research at Indiana University followed, at which point the loss of her grant money forced Dr. Clark into independent research and consulting. 6 years of that led to fascinating discoveries that we will see here now. Please give a warm welcome to Dr. Hulda Reger-Clark. Dr. Clark, what is the most interesting discovery that you have made in all of your years of research, whether it was in school or in government-funded research or in your independent time?
The most interesting facts that I have come across, I believe, are finding that every disease that we have is caused by just two things: a combination of a parasite and a pollutant. No matter what the disease is, it's a parasite and a pollutant, just at a different place. So whether it's cancer or diabetes or migraines or whatever it is, look for the major parasite and the major pollutant, and that's what is actually the dominant cause of that disease. So going back to cancer, the parasite there is a human intestinal fluke, and the pollutant is isopropyl alcohol. That creates the malignant aspect of a cancer.
Thank you. Are there any other questions for Dr. Clark?
Yes. Dr. Clark, so how did you determine that it was that particular parasite that was connected with cancer?
Good question. We want to be very sure. And it's this electronic setup called the Syncrometer that allows you to look into the human body searching for the parasite. It also allows you to search for the pollutant. So that's how I can be sure that the parasite and the pollutant are identified correctly.
What can you test with the syncrometer?
Oh, just about anything. You can use these two test plates which are part of the syncrometer to put almost anything into the testing circuit. You can you can represent your body parts with tissue slides. You can use compounds or things that you're eating. You can test for pollutants in something, some vitamin or other product that you're eating. And it's just about anything that you can investigate that way with this device.
Dr. Clark, what are the limitations of the syncrometer?
There are limitations, of course. You can't test anything quantitatively. You can't say how much of a pollutant or how many parasites there are. And of course it doesn't draw a picture for you. But you can get a picture in your mind, a chemical picture, or an identification kind of picture. And so there are more limitations, I'm sure, than that, but those are the two main ones that I find.
Is the syncrometer patented?
No, I decided not to patent it. I thought it would be much more valuable in everybody's hands. And for that reason, I wrote out the circuit so that anybody can make it and thereby help themselves and their family recover from their diseases and help each family and from that all of society.
Well, thank you very much, Dr. Clark. I really appreciate the question and answer period. If you don't mind, now we're going to get started with lesson 1. There are a few things to remember when using our syncrometer. First, we'd like to remove any bracelets or necklaces that we were wearing. They may interfere with the test results. Second, we want to make sure that the test plates of our syncrometer are clean and free of solvents or contaminants. Cleaning your test plates is very important. You must never touch your test plates or leave a contaminant behind. If that happens, what you're going to do is leave behind a contaminant that you could be testing for each and every time you do your probes. So your test plates must be kept very clean and very pure at all times. Another thing that you need to remember when you're using your syncrometer is that your body tends to go into cycles. You'll recognize the cycles in either a very, very high pitch, no matter what you do, or a very low pitch. When this happens, rest for 10 to 20 minutes and come back to your syncrometer. If the pitch hasn't returned to normal, rest again for another 10 to 20 minutes. Within a half an hour or so, you should be able to get your standard tones back again. There are 5 major variables that need to be working with one another in order to get accurate and consistent readings. The first of these variables is moisture. Moisture is present in 2 areas working with the syncrometer. First, the handhold. This handhold you want to make sure is very wet and very moist all the time. That when you pick it up, you actually get a couple of drops out of it. So your hand is wet when using the syncrometer. The second area where you want moisture to be is on the area of your finger that you're going to be probing. You dunk your finger into the bed of water and then you dry it off on a dry paper towel, leaving behind just a very slight film of moisture. The second variable in working with the syncrometer is the pressure. When practicing the probe, it's a double pressure. You set the probe down on your finger and you give it a good push, you reduce the pressure, and then you reintroduce the pressure to just about the same point again. So what you're getting is a wave of tones that sound identical on both sides. So it's a push, reduce, and push. When you're reducing, you don't want to lift the probe up off of your finger. A single probe should last about 1 second. So when you're practicing, think to yourself, 1001, 1001. So you're giving it a push, you're reducing the pressure, and you're reintroducing the pressure to just about the same point. 1001, 1001, 1001. The next variable to come into play when working with the syncrometer is your timing. Timing is very important. Without it, you're not going to get accurate or consistent readings. Your first probe should last for about 1 second. This probe is going to send a frequency through you and is going to be available for approximately 1/2 of a second. In that 1/2 second is the time where you're going to turn the switch plate on and introduce what is on this test plate into the circuit. So I'll demonstrate for you the timing of your probes. Your first probe is a second, 1001. Let's try that one again, it wasn't very strong. 1001, click, 1001. That's an entire set of probes. That's a test. A single test will last about 2.5 seconds. 1001, click, 1001. Now that you understand the pressure and the timing, the area of the finger that you want to probe is between your nail bed and your knuckle, just above your knuckle, or off to the sides of it. And you can use any of your fingers in that area, including your thumb, to probe. So you moisten that area, you dry off any excess of moisture, you set the probe down flush on your finger, and you give it your double pressure. You get both sides of the probe to sound just like one another. Okay? After you've practiced this for a little while, you're going to throw in the switch. So you're probing a whole set of probes. An entire set of probes needs to take place at the same spot of the same finger. So your first probe is going to be in a spot, then you're going to hit the switch and you're going to return to the exact same spot again for the second half of the test. Both of these probes sound exactly the same. That's referred to as your standard probe or your standard tone. When you've gotten to the point where your first probe and your second probe sound exactly the same, and you have practiced this a lot to get it to sound like this, that's when you can start placing things on your test plates and testing them. Another point I'd like to make when you're probing is to not rest your hands on your table. You don't know whether or not your table is conductive, so it's best to hold your hand up, but hold it firmly so that you're not moving your hands around. And when you're holding it, hold your hand firmly so the probe isn't pushing your hand and you're getting consistent and accurate pressures. Now your first challenge is going to be to practice for about 20 or 30 minutes and see if you can't get your two probes to sound as identical as mine do. Alright, now let's listen to your tone. Okay, one more time. Alright, when you're using the probe, when you set it down on your finger, you want the beginning of your probe to be the same tone as the end of your probe so that you have a very balanced wave. So you give it the same pressure both times.
Yes, I understand. I just get tense by doing this, but I'll try again.
Okay. Without lifting it off your finger in between your probe. Very nice. Still a little bit too hard at the end. Perfect. Practice that one more time. That was very good. Now, you want to do that probe and the next probe in a row that sounds exactly the same. Both exactly the same. Very good. Very good. You are all doing very well. Your probes are sounding much better than when you first started. Remember now, moisture comes into play in two areas. Your handhold must always be kept very moist so that when you open your hand you actually see water. The area of your finger needs to be cool with moisture, so it's just a film of moisture. The pressures need to be consistent so that the tones are identical always. The timing, your first probe is for 1 second. You have 1/2 of a second to turn your switch plate on and begin your next probe, and your next probe will also be for 1 second. So your entire test takes 2 1/2 seconds. All of you have been probing now, and you've all found that wonderful spot that feels good, and it makes the best tone, and you're enjoying probing in that spot. So this spot right here is going to get very tender, so you're going to have to find another area of your finger that you're going to get comfortable with. So what I suggest you do is look for 3 or 4 different spots. So finger properties was our 4th variable. The 5th variable is rest. When working with the syncrometer, once you have a resonant circuit, you need to rest for 10 to 20 seconds after a resonant circuit. If you don't rest for 10 to 20 seconds, it will interfere with the accuracy of your readings.
As soon as you hear resonance, stop probing. The longer the resonant probe, the longer the recovery time to reach your standard tone again. When learning to identify resonance, it is best to rest after each probe.
When working with your syncrometer, there are two different types of tests that you can use it for. One is referred to as an A/B test, which is for products, and you're looking for something in a product. The other test is to look for something in yourself. The first test, the A/B test.
The A/B test is also called the A in B test because we are looking for substance A in substance B.
Okay? The A/B test, your test plates and you. There are three areas that are available in the circuit. The first is yourself, and you are always part of the test. The left test plate is always on, so the left test plate is always part of the circuit. The right test plate has the on-off switch. This is the test plate that you can introduce or eliminate something from the circuit. On your initial probe, you and the left test plate are part of the circuit. When you are looking for a toxin in a product, on the left side, on the left test plate, which is the test plate that is always on, is where you're going to put the solvent.
Examples of solvents are benzene, isopropyl alcohol, and methanol. But you don't have to use a solvent. You can put any toxic substance or anything else you want to check for on the left plate.
The right test plate is where you're going to put the product that you are looking into. So the left test plate and you are in the circuit. So you do your initial probe. On the second probe, you turn on the right test plate, introducing the product into the circuit, and you'll begin your next probe. It is right then where you'll know whether or not this solvent is in this product. Because if it is a resonant circuit and you find this solvent in this product, the beginning of the second probe is going to go very high, very fast, and this is recognized as resonance. You'll know the difference between a resonant probe and a non-resonant probe because you've been practicing quite a bit hearing non-resonant probes. When you probe back to back, and you've been practicing for a while now, you know what non-resonant sounds like. So when you introduce this test plate into the circuit and this solvent is in this product, it will not sound like the probes that you've been making all morning. It will sound different. And the way it will sound different is it will be a very high pitch, very fast at the beginning of your second probe. When you hear this, stop your probe. But don't anticipate hearing it by stopping your probe without having heard it. And I will demonstrate this for you later. The second of the tests that you can use the syncrometer for is a body test. Here again, you and the left test plate are always in the circuit. The right test plate has the on-off switch, and that way you can introduce or eliminate what's on that test plate into the circuit. So it would stand to reason that if you were looking for something inside of yourself, place what you're looking for on the right test plate and leave the left test plate blank. This is you. If nothing else is here, only you are in the circuit. If you're looking for a solvent or a bacteria or a parasite inside of you, place that on the right test plate. Your first test is going to be you, which will just be you. There's nothing here. The second probe will be with this switch plate on, so the only two things in the circuit are you and what you've put on that test plate. And that's how you search yourself. Now, on that particular type of test, it's not as sensitive as if you were focusing the probe on a certain area of your body. A more focused test would be to use slides of your anatomy. If you'd like to focus this particular test on a particular part of yourself, you would place that part of yourself, obviously not your liver, but you'd take a slide, an anatomy slide, of the area of your body that it is that you want to test. So let's say that you're looking for something in your liver. You would place the anatomy slide of a liver here. The frequency of this liver is going to match up with the frequency of your liver, and that's where it's going to focus the test. Now what you're looking for, you put over here. So in my liver today, I'm going to look for the Phaseolopsis busci. That's a nasty little parasite that doesn't belong in my liver, and I'd like to know if it's there. So the first probe is going to be with this switch off. So the first probe is going to direct at my liver. The second probe is going to be with the right test plate on, and then it's going to be searching for the frequency of the Phaseolopsis busci in my liver. And hopefully that's negative. Let's make some substances for you to work with. There are two types of substances. There are pure and there are impure. Pure substances are atomic absorption standards. These you can get from chemical companies, but not everyone can get a hold of them. The best source for a toxic substance kit is your own home. First, you can use rubbing alcohol as an isopropyl sample. The three major solvents in our lives are isopropyl, benzene, and methyl alcohol. Let's make samples of two of the worst solvents. First, we'll use rubbing alcohol as our isopropyl sample. Use a small bottle that is not very thick on the bottom and not concave, so that it sits flush on your test plates. Be careful not to get the outside of your bottle contaminated. If you do, use white tissue, make sure that you get it nice and clean, and your pure water. Don't be stingy with your Kleenex, because you don't want it contaminated on your test plate. It's very important to maintain the outside of your bottles contaminant free. So this is a very nice source for isopropyl alcohol. Now that I have the isopropyl in the bottle, I want to make sure that I always remember what it is that I've put inside that bottle. So it's very important to label. Any substances that you make, you want to make sure that you label. Next, we're going to make a benzene sample. The best source of benzene and the most readily available is the street outside. The asphalt tests positive to benzene. So run outdoors, grab yourself a little bag full of asphalt, and drop a few pieces in a small amber bottle.
Wash your hands after making every test sample. If you prepared the sample in a bottle, rinse the outside of the bottle.
About half of a teaspoon to a teaspoon worth. Then add water to about half.
Many tests can be done without filtered water. Run cold tap water for 2 gallons before using. To be extra safe, you can then run it through a plain carbon filter.
So here you have two impure test substances. The difference between pure and impure substances is that when you're using a pure substance, you can be sure that that's the only thing that you're testing for. When you're using an impure substance, such as this benzene that we've made here, there are other frequencies besides benzene in this bottle. Now, if I test positive to this, it could be the benzene in this bottle, or it could be something else that's inside here. But if I test negative to this bottle, I can be sure that I don't test positive for benzene. So now that we have test substances to test with, we're going to have to make some samples. Now, not everything that you have you're going to be able to test through, so you'll have to make samples. The best way to make a sample is to use a plain Ziploc baggie. Again, we want to use a white, undyed, unfragranced paper towel and rip this paper towel into about 2-inch squares. You don't want to use scissors because scissors are metal, and you don't want any of the particles of the scissors left behind on the paper towel. So place your paper towel inside of your baggie, and then find something that it is that you want to test for. Try bottled water. Any bottled water. Pour just enough into the baggie to wet the paper towel. If you find that you've poured too much, you can always add an extra paper towel to absorb some of the excess moisture.
We have found mercury and thallium in most paper products. You must test your paper for these toxins first.
Close it up nice and tight so that you don't have any leakage. Remember, you want to leave the outside of the baggies clean and contaminant free so that you don't get anything of what's inside the bag on your test plates. It's very important that you maintain cleanliness when dealing with your test plates. Never leave behind something that you've tested. Label your bag. Always put what you're testing inside of a baggie. Never place what you're testing directly on your test plates. There again, you could be leaving behind some of the particles of what you're testing. In something like this, it's wet all the way through, but sometimes when you're testing something, it's not going to go all the way through. When making a test sample out of a substance that isn't quite as liquid as water, you open your baggie, and never by blowing in it, you place the paper towel inside the baggie. Then you take what it is that you want to make a sample out of, and you open your baggie, and you put the sample on the paper towel. About a teaspoon worth will be just fine. Close it up and set that aside. Now you have a nice little dollop of lotion or whatever it is that you're going to be testing. Turn that over. Add a few drops of water just to moisten the outside edges of the paper towel. This keeps your test sample in place and adds a little bit of weight to it. Again, close it completely and label it. Always put the label up near the closure of the bag. Always place what you're going to test down on your test plate. So there is only one layer of plastic between the product and your test plate. So you set that down on your test plate. I did that rather fast. And fold your baggies up this way.
Avoid placing a small test object right over the center screw. It needs solid contact with the plate.
And now you can test with your homemade test substances. Okay, practice your standard tone just a few times before you place anything on your test plate. Okay. Get comfortable hearing your standard tone over and over again. So so that both of your probes sound exactly the same. Let's start off testing our bottled water. It'll be a very interesting test. So here I have the sample on the test plate. Top of the bag is folded over. Let's look for isopropyl alcohol in bottled water, shall we? Oh, wow.
Note, the A and B test is not valid if you have the substance from plate A in your body.
Now, here I'd like to make a point, and that is if your first probe doesn't set well with you, and you haven't thrown the switch and begun your second probe, you can probe again. If your first probe is too low, or it's too high, you can begin again. And you can probe until you've heard one that you're very comfortable with. Okay, now that one would have been a good probe. So I'm going to do that one more time. And I'm going to throw the switch. So listen to the very beginning of the second probe. Okay. That was resonance, and that's how quickly this machine is going to let you know whether or not this is in here. Now I'll have to rest for 10 to 20 seconds before I can continue testing, but that doesn't mean that I can't practice for 10 to 20 seconds. So I'm going to take the isopropyl off of my test plate, but while I'm practicing, I'm going to remove what's on the right test plate. Now if I tested positive for isopropyl alcohol, each time I practiced, and this was on this test plate, then I would be getting a resonant circuit, because this is me on this test plate, and this would be what I was testing me for. And if I had something in me that's in here, I'll be getting a resonant circuit and I won't be resting. So remove anything that would be on the right test plate while you're practicing as well. Okay? You just continue practicing your circuit, your probe, so that both of your probes are sounding identical. The more often you hear your probes sounding exactly the same, the easier it's going to be for you to recognize a resonant circuit. I tested the product twice to reduce the chance of inaccuracy. Since both tests were positive, I can be very assured that this indeed is in my bottled water. Now let's test it for benzene and see what we come up with. Nothing. That was a negative. So there is no benzene in the bottled water. However, there is the isopropyl. Again, I'll demonstrate for you the difference between the positive and the negative. The benzene is negative. Sounds exactly the same. Now the isopropyl. Positive. That's the difference. So that was a positive test. Now the reason why I didn't follow through with the second half of the wave is because I recognized the resonant circuit. The shorter the length of time that I probe during resonance, the shorter my rest period will have to be before I can continue testing. Now that I've shown you how to make your test substances and I have demonstrated the resonant circuit and the non-resonant circuit, it's time for you to make samples of things that you've brought with you. For instance, your shampoo or your toothpaste, your antiperspirant. You can make samples like I did of the lotion and of the bottled water, and you can use the solvents that you've made, and you test each one in turn. Remember to rest each time you've tried a solvent on a test sample. In about 15 to 20 hours worth of practice, you'll get much more accurate readings, and you'll be able to do it a lot quicker, not having to rest between every test. But for now, and until you've learned to hear the resonant circuit, practice with your resting in between every test. And just go ahead and take everything off of your test plates while you're practicing during your rest time. After you've made your test samples and you've tested them, look for something that tests positive for isopropyl reliably. We're going to use that in a later lesson.
spot is a little different, isn't it?
But right on that,
Good.
that point right there.
Can you get your finger too wet?
No, I had a
Yes,
question.
Too much
earlier.
water's bad?
When
if there's
Sergio
too much
did me-
moisture, it will be much too high.
did me
The
here.
sound will screech.
Okay.
Squeal. You don't
You
want it
can
that
find your own spot. It needs to be a spot that gives you a nice low sound
Well said. Very
that
nice.
you can memorize and always go for that sound.
Good. That sounds nice.
Good.
I suggest you use my favorite spots. Right there, just behind the knuckle of these two fingers.
Dr. Clark,
Not on the knuckle, not too far back, just behind. Right. And keep your hand like this so that you're not picking up vibrations from anything that you're touching. And
I was wondering about that.
keep it like this, keep it in
I
there.
didn't hear that.
Don't rest your hand. Keep it up. Perfect. Here's mine.
When I test this, what's in here, I know there's a lot of benzene, and I do it. And the first time I test it, it's beautiful response. Then I try to do it once more, 1 minute later, and the response is not there. What's wrong or what has happened?
If you get a response, if you're getting resonance, that means a high current is flowing through the circuit. That high current affects you. It changes your capacitance and maybe your other electronic properties. And you're not going to test correctly until you're back to your original normal standard state. That's why you're supposed to wait a little while after you have a positive or a resonant response. So you do have to wait that long. Some people have to wait longer than others. You'll get to know yourself, how long you have to wait before the second repeat gives you the same answer.
Sure, right?
What's the minimum time that a person would need to wait? Is it 10 seconds or 20 seconds, 30 seconds?
A beginner should wait 20 seconds.
20
at least.
seconds. 20 seconds minimum.
And then later, when you get to be very much in a hurry, you just have to tell yourself, because I'm going this fast, there's at least 10 or 10% error in what I'm doing. And if this is very serious, a very serious situation, you'd have to do everything twice because you're going too fast.
Carmen, how could I test this pill?
Getting the most accurate results from a test of a pill, what I recommend you doing is taking a plastic baggie and putting a paper towel inside of it, placing the pill on top of the bag, on top of the paper towel in the bag, like that, and using your filtered water, you can moisten up the paper towel, and in about 10 or 15 minutes that pill is going to dissolve enough to be able to squish it and make a little paste. Now it will be about a quarter's worth of a product, and you lay that flat on your test plate.
On this one right here?
Yes, on the right test plate. And the edges of your test plates are more sensitive than the very center of your test plate. So you'd want to lay that. You can take that with the pill in the very center of the bag and fold the bags, the top down and the bottom up, and then have this sitting right there on the edge of your test plate.
All right.
And then you can test it like that. Okay? How are you doing?
Okay, I'm doing pretty good, but I keep forgetting. I do my first probe, I push the switch, do the second probe. Now I'll pick up a different sample. I forget to push the switch back up. I
Okay.
start right on the second.
The best way to keep yourself from continually doing that is to slow down a little bit. Remember that you need to re-moisten your finger. And when you go to re-moisten your finger on your way back, check the switch, see if it's up. So incorporate that into the entire test.
Well, how often do I have to re-moisten?
It's best to do it between every test so that it is a consistent moisture factor.
Why don't we have to take the test substance out of the bottle in order to be able to test it?
Because we are dealing with a high frequency circuit here, And that's what high frequency does. It can jump across an airspace or glass. The glass or the airspace is called the dielectric. And that is part of a capacitor. This is half of a capacitor. And high frequency behaves in that manner. It jumps through capacitors. Everything that is different about a liquid probably has a slightly different capacitance and might change the overall capacitance. Maybe that's actually how this whole circuit works.
Well, Dr. Clark, why can't I just take this bottle of vitamin pills and put it on
Yeah.
instead of putting it in a bag?
Well, you could, but often the plastic is so thick that it gets to be a little too far away from the plate. You should be as close to the plate as possible, and that's why we say use thin plastic for your bag too, and then make sure that what you're testing is as close to the plate as you can get it. It's of course more accurate to take something out and test it. But very often you can test right through the bottle. You might want to put it on its side if it's thinner. If the plastic is thinner on the side than on the bottom. Always look at your bottle to make sure that that the substance you're testing is actually pretty close to the plate.
Thank you.
Don't try to test
Not very strong.
somebody else with any serious implications for half a year.
Oh, for 6 months.
For 6 months. And practice every day so that after 6 months
Very
you feel
nice.
that
Those are
your
sounding great.
conclusions are correct. Work only on yourself for the first 6 months.
Dr. Clark, the equipment is so easy. Why did it take so long to come to your conclusions?
Actually, this should have been discovered 50 years ago because the equipment is so easy in its design. And it's very elementary radio electronic sets involved here. You're right, it should have been discovered. Maybe somebody did 50 years ago, but it's very, very hard to bring anything like this to the attention of society.
Perhaps because there was not enough pollution.
There was quite a bit less pollution than we have now. Now we have a terrible problem with solvents. The gasoline industry has gotten into the food industry, and so nearly everything is polluted with just a trace of solvent or heavy metal or something like that.
Are there any questions?
I can see how you test yourself, but how do you test somebody else?
You can test someone else by using their saliva. If you use a Ziploc baggie and a paper towel like I demonstrated with the other substances that we tested, you can put a piece of paper towel in the bag and you can have the person spit on the paper towel. And then you can add a few drops of water just to keep it moist. And you can place this on the test plate just as though it was a product, and you can test it for anything that would be in the saliva. Almost everything that the body is polluted with will show up in a saliva sample. There are a few exceptions. Those include the HIV virus. It will not be found in the saliva at first, and some of the tapeworm stages won't be found at first in the saliva sample. But most everything else that's toxic you'd be able to locate using a saliva sample. Dr. Clark, do you have any additional advice for our students?
The best advice is just to practice, practice, practice. Don't give up after your first few tries and you think that you can't do it. Anybody can do it. Carmen has given a very good description of all the details, and I know that you can learn it from that. The main points, I'll just review a few of them, are to make sure that you select a nice low sound to start with. Stick to these areas on these 2 fingers, even though other areas might work later on for you. Make sure the plates are clean. Remember to keep your fingers wet. Remember to keep the handhold wet. Remember that you will get it eventually. You have to. There's no way that you can not get it if you keep practicing. Just give yourself the kind of tests that are the most interesting to you, the things that you think are actually your problems. That keeps you pretty riveted to practicing. This is probably the most powerful device there is to make tests on your body that are meaningful and will be very useful to you. You can test anything in anything with reference to your body. For instance, a parasite and a tissue sample can tell you whether the parasite is in that particular tissue or any other organ in your body.
The tissue slide's own frequency acts like a crystal, allowing only this frequency to pass or dominate the circuit. Since this frequency matches your own organ's frequency, you are selectively testing at this organ.
All it takes is 1 minute of testing. Like that. Obviously a negative, and I'm glad I don't have that large beast in my body. If you do, exterminate it at once. Now you can test your body for any parasite in any organ or any other toxic substance. So practice, practice, practice. Don't give up, and pretty soon you'll be an expert at testing yourself. Wait 6 months, and then you will be an expert at testing others too.
Now that you've practiced hearing your standard tone and listening for resonance, one of the best ways to check your accuracy is to take a set of bottles and have a friend or family member fill them for you and number them. And only they know which ones have the isopropyl alcohol or the water. And test each one of these in turn against a product that you know has tested positive for isopropyl. So you would take one of the bottles, you start with number 1, on your left test plate, and on the right test plate you can take your sample that you have tested over and over again positive for isopropyl and practice your probes. Test it. If you hear resonance, set it aside and remember to rest between 10 to 20 seconds, and then bottle number 2 and test that one. After you have your results, have your friend or family member check for your accuracy. After 8 to 10 hours, my students generally come up with a 70 to 100% accuracy rate. Keep practicing. Remember, listening to your standard probes are going to help you identify the resonant circuit.
If you do poorly, wash your hands, all the bottles, and the test plates with plain water, and rest for half an hour.
There's some very important things that I'd like to send you off with. First, I want you to remember that you have learned today how to probe properly. You've learned all of the variables that come into play when you're setting the probe down on your finger. You've learned how to make test substances so that you can test them accurately and feel confident in your results. And you've also learned what a syncrometer can do for you, how it can affect your life, and how you can feel more confident about your lifestyles. I'd also like to thank Dr. Clark for joining us here today. It has been an absolute pleasure having you to stay with us today.
If I want to work with a syncrometer, how can I get one?
Well, you can buy one, or you can build one yourself at home, and we're going to show you how.
Hi, now we're going to build our homemade syncrometer. When building our syncrometer, we have to become familiar with the names of the parts that we're going to use. Some of these parts are leads.
A lead is just a piece of wire used to connect things.
There are 3 different types of leads. This one is the alligator clip lead, and it's called an alligator clip because of the clip looks like an alligator mouth. The second type of lead that we're going to use is a mini hook lead. When you push the bottom up, it looks like there's a little miniature hook there. The third lead has an alligator clip on one end and a banana plug on the other. There are 4 parts to this testing device. We're going to build all 4 of them. The first part is a test surface. The second part is the probe and handhold, and then there's the speaker, and then there's the circuit. So let's get started with building the test surfaces.
You may build a test plate box out of a cardboard box, such as this facial tissue box, or a plastic box. Here are the instructions for the cardboard box model. You will also need stiff paper, aluminum foil, 3 bolts, and 4 nuts that fit. The bolts should be at least 1 inch long. These are 2 inches, and it doesn't really matter. And 6 washers. Also a toggle switch that has an on and an off position. And lastly, 3 alligator clip test leads. Their colors don't matter. Start off by cutting 2 3.5 inch squares out of stiff paper, such as a milk carton or what we're using our paper plates. Then cover them with about a 4.5 inch square of aluminum foil. That means that there's about a 1/2 inch margin all around the edge. Smooth the foil down evenly and tuck it snugly under the edges. Turn the tissue box upside down and imagine where the squares are going to go, but we won't actually mount them now to save wear and tear on them. Next, we mount the on-off switch on the front of the box underneath the right-hand plate. To do this, you'll have to open up the bottom of the tissue box to make it easy to get inside. Pierce a hole the size of the switch and mount the switch from the inside. Line it up so that on is downward and off is up. This is the opposite of a light switch. If your switch is not marked which way is on and which way is off, then ask an electronics shop to tell you when you make your purchase, and then mark them clearly. Label the box on and off. Next, mount the bolt that we're going to use as a terminal. It will be under the left-hand plate. Poke a hole and put a nut on the bolt halfway. And a washer. It doesn't matter whether you mount the bolt from the inside or the outside. It'll stick out halfway each direction, followed by another washer and another nut. Tighten it there hand tight. Label it terminal. That merely means a connecting place. Finally, we'll put the plates on. Poke a hole in the center of each plate. Mount the plates and poke a hole in the tissue box. Using a washer and a bolt, fasten the plates to the tissue box. Put a washer and a nut on the underneath side. And again, you can just fasten them hand tight. You don't need to use any tools. Finally, we'll connect them all together. The left side connection, the terminal, gets attached to the left plate bolt with an alligator clip. Use another clip to attach the same left plate bolt to the on-off switch. There are two connections on the on-off switch, and it doesn't matter which one you use. And the third clip connects the terminal of the on-off switch that you didn't use to the right-hand plate. Make sure the connections on the switch are not touching each other. You might want to put a piece of tape between them to guard against this. All these connections should be checked carefully to make sure they're not touching others accidentally. But if you leave the box open, you can see any problems and use tape around the connections to prevent any accidental touching to the wrong connection. To summarize, the current will come in at the terminal, go to the left plate, over to the switch, then if the switch is turned on, it will also go to the right plate. second part is to construct the probe and handhold. These are what you grasp when testing. For the probe, we're going to use a test lead that has an alligator clip on one end and a banana plug on the other. Take a pencil or pen and tape it to the banana plug so as to give yourself a comfortable grip. The other end will be connected to the circuit when we build it. For a handhold, simply use a 4-inch piece of 3/4 inch copper pipe, which a hardware store could just saw off for you. Connect it to the circuit with an alligator clip test lead.
The copper pipe will always be covered by paper during use.
The third part is the speaker. The Archer mini amplifier speaker is inexpensive and small, about the size of a transistor radio, making it easy to take with you. It needs one 9-volt battery. Remove the screw at the center of the back of the speaker to gain access to the battery compartment. Also, get an 1/8-inch phono jack. Unscrew the plastic housing on the jack to expose the 2 posts for attaching wires. Each post should have a small hole in it to attach a mini grabber lead. If there are no holes, use alligator clip leads, but slip a piece of plastic tape between the posts to make sure the alligator clips do not touch each other. Plug the phono jack into the receptacle marked input. And when we build the circuit, we'll show you where to attach the other ends. If you don't have an Archer mini amplifier speaker, you can use an ordinary speaker. Simply clip it with micro clips to the positive and minus speaker posts, and we will show you where to connect the other ends when we build the circuit. However, it is very important that the speaker be high quality to help you distinguish the sound of resonance. And finally, part 4, building the circuit itself. You'll need the following components: a 3 AA battery holder, a potentiometer and knob if you want a variable resistor, but for simplicity we're going to use a fixed resistor, which is much easier. An ordinary switch, which can simply be a light switch or a switch like the one shown, which is available at an electronics store. A 0.1 microfarad ceramic disc capacitor, a 0.0047 microfarad ceramic disc capacitor, a 2907 PNP transistor, an audio output transformer, 900 ohm center tap to 8 ohms, and 3 size AA batteries to put in the battery holder. To connect everything, you'll need about a dozen microclip or alligator test jumper leads, a shoebox to hold everything, a pointy nail or pair of scissors or paper clips to help poke holes. It's easy to get electronic components confused. Here's a tip. As soon as the component comes out of the package, write down its value and label it clearly. This is a 0.1 microfarad capacitor. The other capacitor is a 0.0047. The resistor we're using is the value is 1,000 ohms or 1K. By labeling them as soon as you take them out of the package, there's no way that you can get them mixed up. Nor does using the tape on them hurt them electronically. Finally, note that the transformer has two sides, one of which might be labeled with a P for primary. And we will show you how that goes in correctly when we get to that point. Finally, note that the transistor has one flat side on it, and again, that will help you determine the correct way of placing that component in the circuit. Directions. Get a shoebox. If you have access to one of Dr. Clark's books called The Cure for All Cancers, then photocopy this picture out of her book. If you do not have access to her book to photocopy the picture, then draw it inside the shoebox based on this same diagram. Then take the picture in the bottom of the box. Note that the light switch is on the side of the diagram, so pierce a hole near the edge of the box for the light switch and mount it. Mount it in the regular way so that on is up, and label the box clearly. Then turn the switch off before continuing. As previously explained, we're not going to be using the potentiometer, which is a variable resistor. We're going to be using a 1K fixed resistor. Pierce two holes where the potentiometer would have gone. Then bend the leads on the resistor into a U shape and insert them into the top of the box. On the inside of the box, you can spread the leads out a little bit to keep it from falling out. Next, pierce holes in the box with a pin or paper clip for the 0.1 microfarad capacitor and the 0.0047 microfarad capacitor. Again, spread the leads on the inside to help hold them in place. Next, we pierce the holes for the transistor. Examine the transistor. Hold it in your left hand with the flat side on the left and the wires pointing up at you. Notice that the center wire is the base. Bend the base wire away to the left slightly so you will be able to insert the transistor into the triangle of holes you made. A diagram on the transistor tells you that the top wire is the collector and the bottom wire is the emitter. Insert the transistor from the outside of the box so each wire goes where it's supposed to. And bend the wires sideways on the inside to secure. Pierce 8 holes for the transformer. Some transformers only have 7 wires and would only need 7 holes. All wires should have their ends bared and available for connections. If they are not, strip away 1/4 inch of insulation and twist the strands of wire together on each wire to keep them neat. This transformer we're using doesn't have wires and is already stripped. Notice that the transformer has 2 little mounting tabs. Once the transformer is mounted, bend the tabs inside or outside to keep the transformer firmly in place. Or, tape the transformer to the outside of the box. Next, we will be installing the battery holder. It's very hard to find a battery holder that holds just 3 AA batteries. Much more common is the kind on this instrument, which holds 4 AA batteries. If you can only find a 4 AA battery holder, take a paper clip and use it to connect the 2 ends of one of the battery slots. Take your 3 AA battery holder and pierce holes for it in your shoebox. Mount the battery holder to the outside of the box. Because battery holders are hard to secure, the best thing to do is to install the batteries and tape the battery holder to the lid. You have finished putting all the components on your syncrometer. The next step is to connect everything with wires. Use 9 microclip test jumpers to make the 9 connections drawn. The first connection is from the resistor to the black or negative side of the batteries. Pull on each connection after you make it to make sure that it's secure. The second connection goes from the collector on the transistor to the 0.1 microfarad capacitor. The third connection goes from the base of the transistor to the 0.0047 microfarad capacitor. Make a slit on the side of the box for the extra wire to keep it out of the way. Make slits wherever you need them. The fourth connection is from the 0.0047 capacitor to the 0.1 microfarad capacitor. The fifth connection comes from the 0.1 microfarad capacitor, where you just clip the last connection, down to the transformer. Connect it to the side of the transformer that's facing the transistor, or the primary side, the one that's marked with a P. Do not clip it to the center post of the transformer. And the sixth connection comes from the emitter of the transistor. That's the wire that doesn't have a connector to it yet, and goes to the light switch. You may wish to use an alligator clip if the light switch doesn't have a nice hole for the microclip. The seventh connection comes from the collector of the transistor, which already has a clip on it. The collector is the one that's nearest to the batteries, and it goes to the transformer on the opposite side of the connection that you made earlier. The eighth connection comes from the middle wire of the transformer. And it goes back to the black wire of your batteries, or the negative side of your batteries, that your very first connection was attached to. Your ninth microclip goes from the red or positive wire of the batteries to the switch. Remember, your switch should be off while you're constructing this project to avoid any accidental electrical discharge. That completes the 9 connections for the syncrometer. It looks messy, but each one is secure and attached correctly. Now to connect the pieces that we made earlier. Start by connecting the test plate shoebox with an alligator clip test lead to the capacitor where shown. Next, connect the probe to the fixed resistor and the handhold to the 0.0047 capacitor. Please refer to the diagram that we showed you earlier, because it does make a difference which capacitor wire you connect it to. Lastly, connect the speaker to the opposite side of the transformer from where you've made your irregular connections, using the two outside wires, not the center wire. Take a look at the speaker and find the one connected to the long post, and connect it to the transformer wire that's closest to the batteries on the side opposite the ones that you've made your connections, and the wire from the short post of the speaker to the transformer wire closest to the edge of the shoebox. Again, look closely at the diagram to make sure you have these connected correctly. Finally, make sure all of your connections are secure. And you're ready to test the syncrometer. Start by wetting a paper towel and wrapping it around the handhold. This protects your hand from coming into contact with the copper. It has to be wet or else electricity will not flow. Next, turn on the speaker and turn the volume up almost halfway. Turn on your syncrometer. Briefly touch the probe to the handhold. You should hear a cracking sound like popcorn. Now try touching the probe to the left test plate. If you don't hear anything, try touching the handhold. Either one or the other will produce a popping sound, but not both. Whichever one produced the sound, use that to touch the right-hand test plate. That one will only produce a popping sound when the switch is on. Now you know that everything has tested out correctly. Try doing a probe. Adjust the volume of the speaker as necessary. Finally, get started testing whatever you wish.
I hope you've enjoyed learning how to use a syncrometer and learning how to build one. For less than $35 in parts, you can build your own syncrometer that works just as well as the ones that we use in our training classes. Remember to practice and stay healthy.